Consider the region between the graph of y equals x squared minus 19 and y equals 2x minus 4. Answer the following. Set the definite integral that represents the area of the region. So I have to set the integral. There's the answer. How do we get that kind of thing? Well, a couple things we got to figure out. First off, we got to figure out where these two graphs intersect. So step one, where the graphs intersect. So to figure that out, this equation, you got to set them equal to each other. So x squared minus 19 equals 2x minus 4. Because where they are equal to each other is where they intersect. So how do you solve this? Well, you got to get, step one, get 0 on one side. So subtract 2x, add 4, subtract 2x, add 4 to both sides. Boom, boom. This is 0. And this is now x squared minus 2x, and then minus 19 plus 4, what's that? Minus 15, right? Okay, now step two is factor, meaning, with the parentheses, or you could do the quadratic formula. I'll probably show both just because I'm instructing this and want it to be clear. Negative b, remember, plus or minus the square root of b squared minus 4ac all over 2a. So this is quadratic formula equal to 0, or you can do either way. So I'll show the factoring way first because that is quicker. If you remember factoring, this is quicker. X is in the front. What multiplies to be 15? 5 times 3, 3 times 5. What adds to be negative? Whatever sign's in the middle goes on the bigger one. 5 is bigger than 3. That's plus. Because minus 5 plus 3 adds to be negative 2. They multiply to be negative 15. And then remember, you set each one equal to 0 separately because they're multiplying, right? So if two things are timesing to equal 0, either one could be 0. To make them multiply and be 0, then you just jump the 5 over, jump the 3 over. So it'll actually end up being plus 5 and or minus 3. So those are the two answers. You can do the quadratic formula also. Maybe I'll just do it right over here real quick. So if you wanted to do the quad, you could. So this is your A would be 1. So I'm just showing the other way. B would be negative 2, C would be negative 15. So that'd be negative B, negative 2, plus or minus the square root of B squared minus 4 times A times C all over 2A. And so that's going to be double negative positive 2 plus or minus 4 plus 60 because negative times negative. Two negatives make positive over 2. So that's going to be, let's write this way, it's going to be 2 plus or minus the root of 64 over 2, which is 2 plus or minus 8 over 2, which is 2 plus 8 over 2, or 2 minus 8 over 2, which is 10 over 2, which is 5, or negative 6 over 2, which is negative 3. So same two answers, right? 5, negative 3, 5, negative 3. Whether you do the quad or you factor, that's why I say factoring is quicker. Either way, get those two answers. So that's where the graphs intersect. At least those are the x values. Let's get the y values now. So I'll take each of those x values separately. So I've got x is 5, and I got let me do that one first. And you got to find the y. How do you find the y? Plug into either equation. It'll come out the same. I'm going to grab this one a little bit easier, but well, I don't know but they're about the same. It'll come out the same answer either way. So I'm going to grab that y equals 2x minus 4. They're going to have the same y value. Plug in the 5 at those x values because they intersect there. So that's going to be 10 minus 4, going to be 6. And then the other one is x equals negative 3, right? Let's plug into the same exact equation. Or you can plug into the other one. Again, it doesn't matter. It'll come out the same either way. They intersect there. So you get, what is that? Minus 6 minus 4, minus 10. So we got 2 points. This is the point 5, 6, right? X, Y, X led to that Y. Or the other one is negative 3, negative 10. X, Y, X, Y. Okay. So we got the 2 points of intersection. There's where the graphs intersect. Now, so that means, let's go on to what that means. So that means in that region, we could just think about a basic graph now. Find which is on the top in which is on the, let's just say top or bottom in the region between the x values. Let's just say between the x, let's just say between the x values. So that's our second step. Find which function, which function's on the top or bottom between the x values, right? So what are the x values? Well, there's one x value, there's the other. So we're going, let's do a little graph thing here. We're going on a graph. If I make say this is 0 or whatever, we're going from -3 all the way to +5, right? -3, +5. Those are the x values. X is -3, 2x is +5. The two x values where the graphs intersect. And the question is, which function's on the top or the bottom in that region? Well, you just plug in a number in that region. Plug in a number in the middle. I'm going to plug in 0 because x equals 0 is clearly between x is -3 and x is +5, but it doesn't have to be 0. Plug in +1, +2, +3, +4, -1, -2. Any of those would work. So I'm going to plug in x equals 0 to what? To both equations, the original two equations, meaning this guy and this guy. X squared minus 19. So the first one and the other one, y equals, what was it? The other one was 2x minus 4. Okay. So I'm going to take that 0 and pop it in and pop it in. And I get, that's pretty easy math, minus 19 minus 4. So this one's on the top and this one's on the bottom. Because minus 19 is under minus 4, obviously. So that means we have the 2x minus 4, the line. I'll just do it. I don't know where it is exactly, but I'm just going to say, hey, that means the line y equals 2x minus 4 is on the top, and the curve, the parabola, well, that wasn't very good. So I got to go through this point and this point to the best I can. All right, not bad. It's got to be on the bottom, right? That's the one, the y equals x squared minus 19, right? Because I know this is a U-shape. X squared is a U-shaped parabola. It's going up because of positive x squared. And I know this equation here is a line. It's straight because it's x to the first power. And I know it's on the top, obviously, and this one's on the bottom. All right, between, and I know they intersect at -3 and +i. So I know that's generally how they look. So that gives me enough information to get the integral, right? So I'm going to go, okay, so the integral is going to be, the integral from the left to the right, because they're wanting a dx, aren't they? Let me go back up here. Yeah, they're wanting a dx integral. Dx, that means along the x-axis. From the left to the right of whatever of the height, right? Because we're imagining we're going to figure this out with a bunch of rectangles times the width for each of those, right? Because let me show you what we're talking about here. We're talking about putting rectangles like this to figure out the area between these two graphs, right? Rectangles like that. Each of these rectangles, put in a couple of them. You know, I don't like that I didn't do them well. All right, let's try it again. Each of these rectangles has a width. We're going to sum up, add up each of these. Each of these has a dx. We want to find the area here. Each of them, the width is dx. That's the width. of each rectangle. And the height goes from there to there. That's the height. So for each rectangle, to find the area of each rectangle, it's the height times the width, right? Every rectangle is length times width, and we're going to add them up. So this means it's a big S, sum up from left to right. So that's going to go from -3 to +5. You go from -3 to +5. The height, and what's the height? The height is going to be the top minus the bottom, right? Top minus bottom. And which is the one on the top? Well, it's this one. So it's 2x minus 4 minus the one on the bottom, which is this one, x squared minus 19. And all of that times dx, because that's the width. So the height is top minus bottom is this minus this. That's the height, right? That's the height of each of these rectangles. Top function minus bottom function gives you the height, right? When you have a top and a bottom, subtract them, you get the height times the width dx. That's the area of that rectangle. Add up all those rectangles from -3 to +5. And so there we go. You can simplify that if you want one step. You can just type that in, it'll work, but I'll go -3 to +5. Then I'll take this 2x minus 4 and then distribute that minus. I get minus x squared plus 19 dx. You can do one more step if you want. This would be a 2x minus 4 plus 19. Going to be plus what? 15 minus x squared there. Is that what they got? 2x plus 15 minus x squared. Let's see. Minus x squared, 2x plus 15 dx from -3 to 5. There we go. So there's the integral all set up that if we can't, we're not going to calculate it. We're just doing the setup. We don't want to use it. We could do it. You did it earlier in earlier sections. We just don't want to make these too long. They're long enough as it is. But there's the setup of the integral that would find the area between those two graphs. Let's look at the actual picture. Here's the actual picture of the functions. Here's the straight line. See how they intersect at -3 and +5. See how the parabola is underneath it, just like we thought. Find this area between them. There we go. It's going to be the integral, the sum of the rectangles that have this height times this width, top function minus bottom function. There we go.